keeping on going with the algebra review. Here we've got some systems of equations. So this on number 6 says solve by graphing. So I can see for the first one, I've got a b of positive 3. Then I've got an m of negative 5/3. So I count down 5 and 3 to the right. Let's go ahead and do that again. Down 5 and 3 to the right. Connecting those dots. The other one has a b of negative 3 and a slope of 1/3, so I go up 1 and 3 to the right, and you can see that's the point where they intersect each other. So that intersection point right there looks like it's where x is equal to 3 or y is equal to negative 2. All right, I like that purple color, so I'm going to use it for number 7. Solve by substitution. I can see that y equals x minus 1, so I can replace the letter y in the second equation with x minus 1, like that. So then I have 2x, I'm going to distribute, minus 3x, distribute, double negative becomes a positive, 3 times 1 is 3. I've got these x's on the same side, so I can combine them. 2 minus 3 is negative 1. If I wanted to, I could have just written negative x. Then I'm going to get the 3 on the other side. Minus 3 cancels plus 3. So negative 1x is negative 4. Dividing by both sides by negative 1 gives me x equals 4. Still have to find y, but at the very beginning I know that y equals x minus 1. So y is 4 minus 1, which is 3. So my solution is x equals 4, y equals 3. Or if you want, you can write it as the ordered pair 4, 3. All right, scooting on down. Got a couple more systems of equations. Number 8. I feel like doing this one with elimination. What I'm going to do is the x's don't really match up and the y's don't really match up, so I'm going to multiply the bottom equation by 3. Because if I multiply the bottom equation by 3, then both equations are going to have 3y in them. So now I have a 3y in my top equation and a 3y in my bottom equation. I'm going to ignore the middle equation. I don't really need it anymore. Then I'm going to go top equation minus bottom equation. So again, just kind of ignore the middle equation. We're just going to go top minus bottom. So negative 3x minus negative 15x. Because I have minus negative, I'm going to think of it as negative 3 plus 15. That's where I get 12. 3y minus 3y. Again, top minus bottom, ignoring the middle. 3 minus 3 is 0, so I don't have any y's. Top minus bottom, 3 minus 39 is negative 36. Get x by itself. So x is equal to negative 3. I'm not quite done. I still have to find y. Now I'm going to go back and use that equation that I was ignoring for a while. And the only reason I'm using that one instead of the other one is because it has a single y instead of the other one has 3y. And I take this x, I'm going to plug it into that equation that I just circled. It says negative 5x plus y equals 13. Negative 5 times negative 3 is positive 15. 15 plus y is 13. Subtract 15 from both sides, you get y is negative 2. And we knew x was negative 3. So that's the solution. Negative 3, comma, negative 2. Number 9 looks just like a substitution problem. So let's put those x plus 3 for the letter y. See what happens. Distribute, distribute. And you might notice that negative 3x plus negative 3x is eliminated, 0. Then I have 9 equals 4. 9 does not equal 4, so there's no solution. No matter what I do, I won't make 9 equal 4. All right. Looks like we got a little bit of exponential problems down here. When I'm looking at this problem here, I can see that 2 times 6 is 12, and 12 times 6 is 72. And in fact, 1/3 times 6 is equal to 2. If you have 6/3, that's 2 whole things. So this is a pattern that starts at 1/3, and then it multiplies by 6 every time x goes up by 1. That's it. Number 11, we're just simplifying the expression. So when I'm multiplying, I add the 2 powers. When I have a power to a power, I multiply the 2 powers. When I have one divided by the other, I subtract the 2 powers. When I have power to a power, I multiply the 2 powers. And that's it. So please let me know if you have any questions. Thank you for watching.